Okay, welcome to Delayed Choice Quantum Eraser, a lab version. This might be the zaniest one yet. So if you thought you understood physics now, which probably is the minority of the people who've seen a bunch of these lectures, after this one's done, you're not going to think so anymore, quite possibly. So I am Robert Nemiroff. This is Michigan Tech. And this is a class being taught for credit. And you can get the lectures on Starship Asterisk. You can get them on iTunes right now. You can get them any number of ways. You don't need a textbook, just need curiosity. Don't need a lot of math either. Staying away from the math because the concepts are the cool stuff. All right, let's get to this. So the delayed choice quantum eraser, I of course did not invent. This has actually been a topic of discussion. It's one of the strangest and most thought-provoking experiments in physics. I'm going to go after the real one. I've talked a little bit about it in previous lectures. So this is based on a couple of papers by Kim and Scully. And actually I was helped by an explanation in Brian Greene's book, Fabric of the Cosmos, which is a good book. And so let's get to it. And you're going to be confused by the next slide, as I was. A daunting slide. No, first I have to do, background work. So we have to understand a concept before we get to it. Spontaneous parametric down conversion. SPDC for people in the know who want to sound cool. So tell that to your friends. It's a process that converts a single photon into a pair of entangled photons. One output photon is typically labeled the signal photon, I can speak, while the other is called the idler photon. So here's the signal photon going up and the idler going down. So here's the initial photon going in, and here's your crystal, which creates a spontaneous parametric down conversion by magical processes we'll consider right now. But you could understand that if you looked at it. That's not what we're going to go after this time. So these are entangled photons. They carry information about each other. Makes 1 into 2. Oh my God, what's happening? It's too much. It's too busy. I want to go home. Well, I'm going to try to step you through it. Actually, you can read those sources if you want to know the details. I'm going to step through a sanitized version of this, which is easier. So here's what you need to know. Here are 2 slits. It's a 2-slit experiment. That's what it is. Here's the north half of the 2-slit experiment. Here's the south half of the 2-slit experiment. There's pairs of entangled photons. So what happens in the north half and what's happened in the south half are entangled. That's what you need to know. The north half is very simple. It's just the 2-slit experiment. The south half tries to figure out what's going on in the north half through complicated mirrors and well, we already did the SPDC one and also photon splitters, quantum splitting as we did last time. Got it? North half, normal double-slit experiment. South half, complicated, trying to figure out what's going on with entangled photons. Okay. Of the north half. So let's go to the next one. Light is emitted toward a double slit screen. As I said, behind each slit lies an SPDC that converts each entering photon into 2 entangled photons. One set of photons, the signal photons, goes north. One set goes south. They're the idler photons. So assuming that 2 possible photon streams heading south are kept separate and strike separate detectors, therefore a southern experimenter would know which slit each southern photon went through. The corresponding entangled 2 photon streams heading north, however, are combined onto a single image screen. What pattern appears on the northern image screen? So you know, the northerner knows that the southerner has the ability to tell which slit the photons went through. But what does the northerner see? He or she is just running a normal double slit experiment. Do they see an interference pattern? Do they see no interference pattern? Or do they see directions out of Crazyville? And drum roll, the answer is no interference pattern. No. Even though if the northerner didn't know there was spontaneous parametric down conversion, they would be confused by this. They can't get their 2 slits to act. They can't get the photons to go through both slits at the same time. They're getting their photons, it seems, to go through only 1 slit at a time, and they're not seeing an interference pattern. So the northerner might know there is entangled photons going south, and just that information somehow is destroying his interference pattern. That's what happens. So we report experiments here, folks. That's what we do. So now we'll call that experiment 1. Experiment 2 is the same as experiment 1, except now some of the witch slit information is erased from the southern photons. So in experiment 1, they were keeping track of all the photons, the entangled photons. They knew which photon went through which slit, and therefore what was happening up in the north. But now some of the southern photons, like we've seen in quantum splitting, you can erase the witch slit information. And so some of them, 2 groups in fact, 2 groups are having their witch slit information erased. So what happens to these distinct groups of southern photons? Do each of these groups continue to show an interference pattern even though witch slit has been erased for them? Does neither group show an interference pattern? Does one of the groups show an interference pattern? Or do the photons just move to an easier experiment? And the answer is each group shows an interference pattern. So in the southern experiment, when you erase the witch path information for those 2 groups of photons, and there were 2 groups that didn't have their witch slit information erased, these, without slit information, they again go through both paths, and you get 2 interference patterns. Here's the really odd thing, though. One of the interference patterns is like this, and the other one is like this. It's down, up, down, always the opposite. So when one interference pattern has peaks, the other interference pattern has valleys, and that will turn out to be important. Still with me? You can stop and go through it again. So, using timing information, timing coincidence information, the northern photons can be found that are entangled with the 2 sets of southern photons that showed the interference patterns. So you remembered that the southern photons were broken into 4 sets, 2 of which showed interference patterns and 2 of which did not. So now we can track which the entangled one, so each of the southern photons is entangled with the northern one. So let's pick out those northern photons that are entangled with the southern photons. We know that altogether the northern photons are not showing an interference pattern. But let's pick out the ones from the south that are showing the interference pattern. What do those show in the north? Do they show an interference pattern? Do they show no interference pattern? Do they show 2 interference patterns superposed? Or does God not play dice with the universe? Answer is, they show no interference pattern and 2 interference patterns superposed. Since they were entangled with the southern photons, they show the same patterns as the southern photons, for which witch slit information has been erased. Therefore, they show 2 interference patterns, but this time they're superimposed on the same screen. Therefore, since each interference pattern was offset from each other, the peaks and valleys filled in. So one was up, one was down, and together they were flat. So it appeared in the north like there was no interference at all. So therefore, all 4 sets of photons in the north combined are not showing interference. But in the south, 2 showed interference and 2 didn't in the second experiment. In the first experiment, all the witch slit information was available. Okay? So let's go and figure out what this means. Therefore, even though the northerner sees no interference pattern, she still does not know which of his northern photons went through which slits. All the northerner knows is that witch slit information appears to be available to the southerner through entangled photons. The northerner thinks that the southerner can use her entangled photons to figure out witch slit information for each northern photon. In experiment 1, the southerner would indeed infer which slit information for each northern photon, for each one. So the southerner knows every slit in experiment 1 that the northern photons went through. That photon went through the top slit, next photon went through the next slit, bottom slit, top slit, bottom slit, top slit, bottom slit, bottom slit. The southerner knows all in experiment 1. But in experiment 2, the southerner would infer which slit information for only some of the northern photons. Therefore, some of the northern photons, the southerner says, went through both slits. So what happens in the northern experiments depends on what happened in the southern experiment. And here it gets weirder. Furthermore, the southern half of the experiment could have been chosen to be either experiment 1 or experiment 2 years after the photons have impacted the northerner's image screen. Whether some northern photons take one path or both paths depends on the southern experiment that can happen years in the future. The present depends on the future. Whether the northern experiments take one path or both paths depends on an experiment in the south that hasn't been done yet. Got it? Got some laughter here. This is quantum mechanics. Finally, no matter which experiment the southerner does, whether it's experiment 1 or experiment 2, the northerner will see the same result. The northerner will see no interference pattern. Their photons will come in just like they always did. No interference pattern ever. Doesn't matter what the southerner does. The northerner measures the same. The southerner can show up years later and say, I know which slit this photon went through, or I know that this photon went through both slits. And they would be right. But that would be later. There is no way the future can send a signal to the present, at least not with this experiment, at least so far as we can tell with quantum mechanics. And with that, I will leave you with one of the strangest results in quantum physics and possibly in the universe, and ask you to keep Schrodinger away from your cat. See you next time with even more quantum strangeness.